All right, here's a couple of good questions where you have to determine what formula to use, and then once you've determined that, figure the question out. So it says determine the mass of hydrogen chloride gas. So they're looking for mass. Present in a container has a volume of 1700. Now, just before I go on there, when they're looking for mass, none of these formulas have mass in it. But the one I think I can get mass from is moles. So wherever I see moles, I could use that formula or this formula. Or here's a formula right there with moles in it. Remembering that this formula, moles is equal to mass over molar mass, that's the one that'll convert between moles and mass for me. Okay, so when they're saying mass, really they're looking for moles, and then from moles we use this formula to get mass. Okay, 1700 mils, let's change that to liters, so that'd be 1.700 liters. Pressure 131.2 kilopascals, and as a temperature 30 degrees. Have to convert that to Kelvin, so it'd be 273.15 plus 30. So I think it's 303.15 Kelvin. So all they are doing is giving me sort of the present conditions of one gas. They're not changing the gas to a different pressure, different volume, different temperature. So this formula, this one, this one are all gone. Because those are ones where I start with a certain condition and end with another condition. So I have to use that formula. Okay, so PV equals nRT. And they say, what are they looking for? The mass. So if they're looking for the mass, first I find moles, then mass. So this is what I want to solve for, is the moles. So I want moles on the side of an equal sign by itself, and then everything else over there. So using this formula here, the easiest thing to do to get rid of the other stuff is just to divide both sides. So if I want to get moles by itself, I'm going to divide this side by RT, because when I do that, they'll cancel, and then moles are all by themselves. But if I divide on that side, I have to divide on this side, RT. I like to rewrite, because I'm sort of a left-handed variable guy, I like to rewrite it so I have moles on the left side, and then I just write what that is. So PV equals RT. It's common for students to mix this up, to put one on the top and one on the bottom. So just be careful with that. All right, so pressure, 131.2 kilopascals, times the volume, 1.7 liters, divided by R, which is up there, 8.31. I like to give it a few more sig figs. 8.3145 kilopascal liters per Kelvin mole, and then the temperature is 303.15 Kelvin. Why did I write that down? You already had it up there. Oh, just that one thing there. Make sure you convert it to liters, because that's what our R value is in. Okay, let's cancel. Units, kilopascals, gone. Liters, gone. Kelvin, gone. Left with moles, that's what I'm looking for. Life is good. Okay, so when you put this in your calculator, I would do it like this. Bracket 131.2 times 1.7 bracket, divide bracket 8.3145 times 303.15 bracket. Okay, let me do that. Okay, bracket 131.2 times 0.7 bracket, divide bracket 8.3145 times 303.15 bracket, go. Okay, so that comes out to 0.088489. moles. Now if they're just wanting moles, I'm done. But if in this case they're looking for mass, I have to do this one more step. So the formula is moles is equal to mass over molar mass. In this case, I'm looking for mass. So to get that on a side by itself, I have to get rid of this molar mass. So I'll multiply, because I'm dividing, I'll multiply by molar mass on this side. If I do it on that side, I have to multiply it on the other side. So these cancel, leaving me with mass is equal to molar mass times moles. And I'm a left-handed solver, so I just swap them now. Moles equal mass times molar mass. Moles, I just got that number, 0.0884889 moles, times the molar mass of what? What gas do we have? Oh, it's hydrogen chloride gas. So hydrogen chloride gas, let me put that over here on the side. So hydrogen chloride gas gives one hydrogen and one chlorine. So hydrogen is 1.01 and a chlorine 35.45. So add those together, I get 36.46. So mass is equal to moles, got it, times the molar mass is 36.46 grams per mole. Moles cancel. So now I just times what I had before, times 36.46, go. So I come up with 3.226307, etc. Rounding that, in the question I think there were 3 sig figs. That was the least one that you had. Is that right? Let me just check. Yeah, the 30 degrees just has 3 sig figs. Oh no, hold it, 1700. 1700, let me write that down. So the number 1700, there's no decimal at the end. So this only has 2 sig figs. So my answer, I can only give 2. So it'd be 3.2 grams. Okay, so that's that one. Let's try another one. I think this question is similar to that one. We'll just go with what you had up there. Yeah, and you picked the right formula. Perfect. Numbers are all good. So now I need to manipulate this formula. So it's PV equals nRT. I'm solving for moles. So I want to get rid of the R and the T. So since they're being multiplied on the top there, to get rid of them, I'll divide this side by RT, and on this side divide by RT. These cancel, so I'm left with moles is equal to PV over RT, but I'm the left-handed kind of guy, so it's PV over RT. So the pressure, 17 atmospheres. Uh-oh, trouble. Because my R value is 8.3145 kilopascal liters per Kelvin mole. If I put an atmosphere up top here, that's where I'm going, right, the pressure. If I put 17.0 atmospheres up here, the atmospheres and the kilopascals can't cancel. So I'm going to have to convert that that unit, that's 17 atmospheres, I'm going to have to convert that to kilopascals first. So let's do that. So 17.0 atmospheres times, here's where you'd use those conversion units. So 1 atmosphere is the same as 101.325 kilopascals. So the atmospheres cancel. Now I have to multiply those. So 17 times 101.325. 1722.525. So this is 1722.525 kilopascals. That looks better because then they're going to cancel, right? Times the volume. Where's the volume? Oh, 5 liters. 5.00 liters. divided by R, R's there, and then temperature, right there, 293.15 Kelvin. So Kelvins cancel, liters cancel, so I'm left with moles is what I'm looking for. Okay, so that's 722 times 5 divided by bracket 8.3145 times 293.15 and bracket. So that gives me 3.5335, etc. moles of whatever I have. And it's ammonia. So that's how many moles of ammonia I have. That's the first question. Got it. Now to convert that to grams, because they're looking for grams too, I'll use this formula. Moles is equal to mass over molar mass. I'm looking for mass, so I multiply both sides by molar mass. These cancel. So mass is equal to moles times molar mass. Again, I'm just going to write it. Whoops. Mass is equal to moles times molar mass. I'll just do it so my unknown is on the left side. So the moles, 3.5335 moles times the molar mass of ammonia. So ammonia is NH3. So nitrogen is 14.01. Hydrogen is 1.01, and there's 3 of them. So if you multiply that by 3, you get 3.03. So you add, you get 17.04. So it'd be 17.04 grams per mole. The moles cancel, and when you multiply that, let me get that figured out. 60.211 grams. Now sig figs, there's 3, 3, 3. Looks like 3 sig figs everywhere. So I'd write that as 60.2 grams. Okay, hopefully that helps you with those 2 questions. Now, just as another thing, a number of people have been wondering how to manipulate formulas, and just to make sure that you're doing it correctly. We've already done some in this video using the ideal gas law, but let's try, picking any other formula. Let's say pick this one, so Boyle's law, and say I want to solve for P2. If I want to solve for P2, and solving for that means at the end I want P2 is equal to something. So right now, on the right side of the equal sign, I have a P2 and a V2. I want to get rid of the V2. Since it's being multiplied, to get rid of it, I can divide. And if I divide by V2, they cancel out, leaving me with that P2 by itself. But if I divide by V2 on this side, I have to divide by V2 on that side. So P2 is going to be equal to P1 V1 over V2. Let's try another one. How about that one? And let's maybe solve for T1. Now here's, if you're solving for T1, one of the problems there is that that's on the bottom of a fraction. And you can't just sort of get rid of the V1 at the top and call it good. You have to first get T1 on the top, and then you have to manipulate things. And what we said with this formula, or this one, or this one, or this one, is you can use cross, multiply, and divide to solve for it. So rather than going through mathematical procedures like this, divide on both sides, that kind of stuff, what you can do is just say, okay, T1 is equal to, and you're cross multiplying and dividing. So you multiply the cross, so here's one cross, and then here's the other cross. You multiply the cross that doesn't have the thing you're looking for. So I'm going to multiply the V1 times the T2. So V1 times T2, and you divide it by whatever is in the other cross, other than the thing you're looking for. So you divide it by V2. Let's try this one. Let's maybe solve for P1 this time. So P1 is equal to, here's the other cross, so T1 times P2 divided by the other thing, the thing that's across from what I'm looking for, T2. How about this one? Let's solve, say, for V2. Oh no, let's solve for a different one. Let's do one on the bottom. Let's solve, say, for N2. So it'll be N2 is equal to this cross here, N1 times V2 divided by the other number, V1. How about this one? Oh, it looks like a nasty one. Let's solve, say, for, I don't know, T1. So T1 is equal to this cross, so it'd be P1, V1, N2, T2, that's a big one, divided by everything that's in the other cross that's not my unknown. So it'd be N1, P2, V2. Okay, hopefully that helps you in manipulating the formulas. If you have other questions, of course, give me a call.